Hi, so this question is sum of prefix scores of string. So yeah, you can go through this and then I'm going to explain what's going on. So in the example 1, the words string array is ABC, AB, BC, B. So what exactly is this guy doing? So let's just look at ABC. ABC, which is the first one. All right, ABC you can split to A, comma, AB, comma, A, B, C, right? All right, so which mean what? In A, just look at this. A, how many words, how many prefix for in the string array? It's gonna be 2, right? So this is gonna be 2. How many prefix in the string array is 2, right? A, B, C, how many? Only 1, right? So this is why is 5 for the first index. Let's look at another one. AB. A and AB. Alright. Think about it. A, how many? 2, right? This one and this one. The prefix. And then AB, this one and this one again. So it's 2 plus 2 equal to 4, right? So this is how we get a 4. Alright, same idea. BC and also B. BC you can split to what? B and BC, right? And then B you can only have one correct, right? And then BC just by itself. BC by itself, right? How many for B? 2 for B. Oh, yeah. This one and this one. Sorry. So, yeah. BC, B and BC, you can satisfy this, right? So it's going to be what? 2 plus 1. So this is 2. This is 1, right? 2 plus 1. And B is basically this one, but you only have 2, right? All right, so a little bit, complex, but anyway, uh, let's look at this. I'm gonna take it bigger. All right, so here's it. Um, it actually is pretty straightforward. You can use trial. So let's look at this. ABC. I can create a trial. So TRIE. If you have no idea what's trial, probably you can go to Google first. But I'm gonna explain logic. So ABC is going to be the what? The word, right? So I'm going to create letter A. So letter A. So this is going to be a first level, and then all the way until letter Z. All right, letter A has what? It's going to be starting point, and then you connect to letter V. And in this layer is still going to be from A all the way to Z. And the letter B will connect to letter C. But in this layer, you are going to have your own A to Z, layer, right? So if we traverse, we can actually just increment a count, right? I can say, oh, A is appear once, B appear once, C appear once. So this is A, B, C, right? And then if you go to the next one, A, B, maybe another color, A, B. Since we already have the node over here, right? We increment this by 1, so it's going to be 2. Maybe I can erase 2. All right, the next one is going to be B, right? So we connect from A to here. And then we already know this is the what? This is, the initial was 1, right? And then I increment by 1. So it's going to be 2. So what is the total size? The total count, right? Total count of ABC. Uh, sorry, AB, not ABC. I'm at this index, right? So it's gonna be 2 plus 2, right? So you return 4. All right, let me do BC. All right, BC is this one. B will connect to C itself, and definitely you can have A to Z over here. We're going to increment the count by 1, all right? Every single time by 1. So 1 and 1, right? And then what else? Uh, That's it, right? All right. Anyway, and I know the answer is 3, but hold on, because I need to traverse the next word, right? Next word is gonna be what? Uh, B, right? B is gonna be what? Just increment by itself is 2, right? So when we search BC, we're gonna say 2 plus 1, right? 2 plus 1 is 3, and then B is gonna be 2, right? All right. So first thing is we need to generate a trial first. Then we do the searching, do the counting. So it has to be this order. So I'm a little bit jumping around because I want to skip over the description, I mean, explanation earlier. But this is the idea, right? We're going to build our child first, and then we search the index. I mean, search the count. So, all right, let's see. So what I need is child node. So in the child node, we're going to have what? The list, right? So because every single time we're going to have our own uh, what's that called? Our own A to Z list, right? So child node. This is just initialize the children. So it's gonna be child 26, right? Okay. So I'm gonna have a child no root. So the root is always starting from what? Um, from the top, the first layer. And every single time I want to traverse, I'm take a copy of the root and traverse. So I'm not touching the root, right? So root equal to new child. No. All right. So for string words, I have a function called insert word. All right. So it should be here. Private void insert, and then taking the string word, right? And I take a copy of the root, right? And then I basically traverse the string. So initially, you only initialize the what? Initialize the child node, but you not initialize the children. So A to Z is still not opening. It's still not, available. So you want to initialize. So node dot children C minus A. C minus A represent a letter, right? If this is equal to node, definitely you want to what? Create a node, new child node. All right, once you create it, you want to say node equal to node, child node, and then you increment the count, right? Like you want to go on the next level, right? Go on the next level, and then before you go, sorry, yeah, so this is after you go, right? And then you increment a count. So let's take a little bit example right here. So this is my root. All right, my root does not do anything. So this will be the first layer, A to Z, right? And then once I create it, so I don't have anything because it was null. And then I create it, and I go to the letter. So imagine this letter A. I create a letter A. I increment the count, the frequency. So it's gonna be 1 right here, right? Yeah, that's it. So this is pretty much everything. So once we create the frequency for every single letter, I'm going to have the result return because you want to return the same size of what the in array, right? Cool. So in this case, what we need to do is we want to assign the total, the maximum, the total what? The total frequency, right? For the letter, right? For the letter. So it's going to be search based on index I. All right. So create another function, private in search, taking the prefix, right? So again, it's not going to be a big change. I'm still going to have a copy, and this time I need to return an int, so I need to have a return result. I need to traverse prefix, right? So if the node, yeah, this is actually the same. If you cannot find the letter in the trial node, which means you are stopped, so you can just return result. Otherwise, you're going to what? Pass on the trial, and then you get a count. So node plus it's called val or count. Let me see. A count, yeah. So you're going to plus the count for the node. So again, let's see. Initially, you are at the root, so root is basically nothing, but we already create A to Z, right? And then in A to Z, we only initialize the trial node for the letter in the words, right? So in this case, A is initial, B is initial, right? So if I want to say, oh, the character C, so the first one is going to be what, letter A, right? So A does not equal to no. But what happens if you want to say letter Y? So letter Y is equal to no, right? So you want to immediately return. Like you don't need it. Like this is not initialized in the string array words. So this is how it is, right? Okay. And then you return result. All right. Good. All right. Oh, nice. Oh, okay. So this is the solution. I mean, I have my own solution, but let's think about this. So for the trial node class, all of 26. For the insert, you taking from all of n. So this is all of n, and this is going to be definitely based on your letters. So sorry, it's going to be based on your char, right? So it's all of n times all of w, right? And that would be it. And this is all of n, and search is going to be based on the depth of the tree, so the path. So I believe it's still going to be all of w for the maximum. But let's look at this. I mean, this is not 100% correct, but most likely close. M times M, yeah. It's pretty like my solution, yeah. All right, it's exactly my solution. All right, I mean, my W is M, right? All right, so this is a solution, and see you later, bye.